Are we going to find the sine of double an angle? That's what they're asking. Sine of 2 theta. So again, let me go to the file. I'm going to write the formulas here one more time. Sine of 2 theta is 2 sine of regular theta times cosine of regular theta. And then the cosine of 2 theta is cosine squared of theta minus the sine squared of theta. All right, so getting back, so this is the one we need. So getting back here, so the sine, or here I can bring it down here. So the sine of 2 theta is 2 sine of regular theta times cosine of regular theta. So everybody see what that, do you see the pattern there? You know, math and science all patterns. Do you see the pattern? It's saying if you take the sine of double an angle, 2 theta, you can do that by just putting the 2 in the front and taking sine of regular, see how this is regular theta here, and cosine of regular theta. So it's all about the difference between what's being plugged into the toaster, into the sine, cosine, whatever, or what's in the front. And that's a different deal, huh? They're saying if you have 2 theta plugged in, that's going to be the same as if you just put in regular theta, just sine and cosine, and put a 2 in the front. That's what they're saying. Now, oh, and I'm not showing where that formula comes from. Anyway, let's just use it first, then we'll talk about where. Because I'm just putting it down like it's magic. Like, boom, there it is. But where did it come from? Anyway, we'll get to that in a minute. Let's just use it. So, how am I going to find, so really to do this problem, then to do sine of 2 theta, I just have to find sine and cosine. Plug them in next to a 2 and I'm done. So how do you find sine and cosine? Got a triangle. How do I find sine and cosine when I've got a triangle? SOHCAHTOA. SOHCAHTOA. Right? So this is the opposite side, the adjacent, and the hypotenuse. So sine is opposite over hypotenuse, 3 over 5. So this sine here is 3 over 5. Bring the 2 down. And what's the cosine? Adjacent over hypotenuse, 4 over 5. So there we go. Is that making sense? So I'm just simply using the formula. You'll have this on your 3x5 card for Tuesday's test. Sine 2 theta, 2 sine cosine. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. 2 is in the front. What do you do when you have a whole number interacting with fractions? It's over 1, huh? And so it just multiplies top, doesn't it? So 2 times 3 times 4, what's that? 24? 2 times 3, 6, 6 times 4, 24. 5 times 5, 25, done. 24 25ths. Are we good? Questions on that one? Seeming easy and not too bad? Questions I can answer on that one? And I'll get, all right, I'm going to move on because everybody loves math so much. Or something like that. That's what I tell myself. All right, cosine of 2 alpha. So what we're going to do, can you do the formula? Just try to do the same thing. So just, but this time it's cosine. Cosine. So go grab the cosine formula. Cosine of 2, it doesn't matter what you call it, alpha, A, you just make it X if it bugs you to have that weird alpha symbol. It's just an A, basically. I'm just going to make it an X, whatever. It's cosine squared of X minus sine squared of X, huh? That's what the formula says right here. That's the cosine formula. So if you have the cosine of double an angle, it's cosine squared minus sine squared of the regular angle. So here you have the angle. So you need to find the cosine and the sine using SOHCAHTOA, but that means you're first going to need to find that other side of that triangle. How can you find the other side of that triangle? Pythagorean theorem. Or you could notice. Does anybody notice? Remember the Pythagorean number I told you to look for a lot? 3, 4, 5. A lot of times they use 3, 4, 5 for the sides. Or some multiple thereof. Meaning 3, 4, 5 multiplied by some. you see? What is 6 and 8? This is like the 3 and the 4 and the 5, except they're all twice as big. Yeah, it's got to be 10, exactly. You getting that? Instead of 3, 4, 5, it's 6, 8, 10.
I had to calculate it, but yeah.
Yeah, you can do that. You can do the a squared plus b squared and c squared. I'm just trying to save you time. If that's what you'll get 10. That's what Pauline got. It is 10. Is that making sense? So just look for that, save you some time. 3, 4, let me tell you the two you'll see a lot. 3, 4, 5, and 5, 12, 13. Those are two of the most commonly used, what are called Pythagorean triples. Those three numbers work as whole numbers on the Pythagorean theorem. So just look for those, save you some time. 3, 4, 5, or 3, 4, 5 times something, you know, and 5, 12, 13, or 5, 12, 13 times something. So look for that when you see 6, 8, go, oh, I know what they're doing. They're doing 3, 4, 5 multiplied by 2, 6, 8, 10. All right, so 10. So we have the third side. We don't even have to do the a squared, b squared, c squared. We just do it like that. And we go, okay. So this is the opposite side, the adjacent, and the hypotenuse. So what's cosine? Do SOHCAHTOA. So do your cosine, but make sure you square it. And your sine, and make sure you square it. So what is cosine? Adjacent over hypotenuse. 6 over 10 squared. And what is sine opposite over hypotenuse? 8 over 10 squared. Does that make sense there?
Does it happen to the left cosine?
What's that?
Does it happen to the left cosine by the 2? Or no?
Oh, well, that's what we're trying to figure out. Well, they're saying, find out what this is. And I'm saying, well, it's this minus this. That's what the formula told me. Yeah, so, yeah, I'm just doing the right side, and that will be the answer. Is that good? It's a good question. Is that making sense? And then the right side, that's 6 10 squared. What's that? 36 over 100 minus 64 over 100. What is that? Minus 28. Is that right? 64, yeah, right. Minus 28 over 100. And then reduce that, right? How do we reduce that thing? Well, what goes into 28 and 100? Yeah, 4, huh? So minus 7 25ths, done.
Oh, okay, 36 minutes.
Yeah, right, Jose, yeah, good. We all good on that? Questions on that one? All right, I'll keep moving. Just all making some sense so far? So the first one, so we're using these two formulas right now. If they give me sine of double an angle, I just do that. And if they give me cosine of double an angle, I do that other formula. Right? And I just plug in, and then I just use the triangle and do the SOHCAHTOA thing to find those. Okay. Let's keep going then. All right, so here we go. So they're saying cosine of theta is 12/13. Theta's in quadrant 4, so you know how to do these. You guys are pros at these now. That was those last three in last night's homework, right? And Vera and Ani are fresh off these. That's moments ago, right? These are doable. They're painful. They have us do a ton of these. So you guys are hopefully getting really, really comfortable with those triangles. So fourth quadrant, you know what to do. Put put a triangle in the fourth quadrant, make it go to a right angle at the x-axis, right? We always go to the x-axis, so it's a reference angle. It's relative to the x-axis, with reference to the x-axis. Put theta there at the origin. Cosine of theta is 12/13. Can you do the SOHCAHTOA thing? And put that in the triangle. Cosine of theta is 12/13. So, SOHCAHTOA cosine is adjacent over hypotenuse. This is supposed to be adjacent hypotenuse, so the adjacent side, hypotenuse, the opposite side. So the adjacent is 12, the hypotenuse is 13. Yeah, remember the one I was just telling you? 3, 4, 5, and 5, 12, 13. So you don't even have to do Pythagorean. See how easy this class is?
Mine was 6, 8, and 10 again. So.
6, 8, and 10, nice. Yeah, they use these. So you know it's 5. Huh? You can do the Pythag if you want to. A squared plus B squared is C squared. But that's what you'll find. 5. They use those two a lot. 5, 12, 13, and 3, 4, 5. Is that good? So everybody good to there so far? So we've got our little triangle. Now, what are we supposed to do from here? Well, it's asking me for the sine of 2 theta. What's the formula for sine 2 theta? Well, that's the new one for today. Here it is. Sine 2 theta is 2 sine cosine. Right? The sine, see the pattern again. Sine of double an angle is 2 times sine of regular theta cosine regular theta. So let's go do that. 2 sine of regular theta cosine regular theta. Is that good? Okay, so it's 2 sine theta. What is the sine of theta?
Negative 5 over 15.
Yeah, good. Really, this is a negative 5, isn't it? Because it's right and down. Really, that's a negative 5. You know what I mean? So the sine is opposite over hypotenuse is really minus 5/13. So what's the cosine? Adjacent over hypotenuse, 12 over 13. Is everybody good with that, with the signs there? Or you could do the all students take calculus thing, right? All are positive students take calculus. Only cosine's positive. Here I'm in the fourth quadrant. Only cosine's positive. Cosine is positive 12/13. The other ones are negative, so sine would be negative, huh? So either way, you can either do that or just look at the right and down. The 5 has to be negative, so yeah, the sign has to be negative. On that, multiply that together. What do you do with that 2 in the front? Over 1 goes to the top. 2 times 5 is 10. Times 12 is 120. 13 is 169. It's negative 120 over 169. So it's just the same thing, isn't it? Except with making triangles. And you already know how to make the triangles and the quadrants and all that stuff. But notice that's only one of the 3 questions. They're asking me for sine 2 theta, which we just got. And now they also want cosine 2 theta and tangent 2 theta. We can do that. Let's come on down here. Or maybe I'll go up here. Let me go up here. I'm going to do cosine 2 theta. What's the formula say right here? Cosine of double an angle is cosine squared minus sine squared of the regular angle. Right? Cosine of double an angle is cosine squared of regular angle minus sine squared of regular angle. So it's going to be cosine squared of regular minus sine squared of regular. Okay, so what's the cosine? Well, it's right here. It's 12/13. It's the same triangle, isn't it? I don't have to redo the triangle. Everybody with me on that? Right, I'm going to use the same triangle. Cosine is what it was a minute ago. 12/13. So this will be 12/13 squared. And what is sine? What it was a minute ago. Minus 5/13 squared. We good there? Am I going too fast? Questions so far? Everybody making sense what I'm doing? This good? So you just make the triangle once, and then you've got everything you need to answer all the questions. So then you just write down the various formulas. So let's finish this up. This is going to be, what is this? If you use your calculator, 144 over 169 minus 25 over 169. Subtract those. 119 over 169. That's cosine 2 theta. Part B. See how they have questions A, B, and C? So that's the answer to B. This good? And final question is they want from us tangent, don't they? They're saying in part, so this is part B up here, this is part A right here, and then finally, part C, they're saying, all right, now tell us tangent of 2 theta, right? See A, B, C right there? A is sine 2 theta, B is cosine 2 theta, C is tangent 2 theta. How do I find tangent of 2 theta?
Can we just take the answer that we got from the other two problems?
Beautiful. It's exactly what we're going to do, right? Now, if you click on the Show Me an Example button, they have a special formula for tangent 2 theta. But I would rather not have new formulas if I can avoid it, and I can avoid it. Just put sine over cosine. We've already learned that, huh? Tangent is just sine over cosine. So tangent of 2 theta, double angle, is going to be sine of 2 theta over cosine 2 theta. Makes sense, doesn't it?
We already figured those out. So.
And we've already figured those out. So just pop them in, right? Tangent is going to be whatever answer we just got from sine, which is right here, minus 120 over 169, over the answer we got from cosine, which is right here, 119 over 169. See how that's sine 2 theta over cosine 2 theta? Right? Everybody tracking with me? See that? Yeah, don't do a bunch of new work, just do that. And then how do I simplify those fractions over fractions? You can flip, or when they already have the same denominator like that, just cancel it away. Minus 120 over 119, done. Ani, question?
No,
Comment?
I got it.
Good. Everybody good with that?
I like that. Much better than last night's homework.
Is that okay? We did all 3 parts there. Questions I can answer. So we're getting a lot of skills now. You feeling? That first week we were just laying the foundation, but now we're drawing triangles, finding double angles, half angles in a second, adding angles, subtracting angles, a lot of different things now. So they're going to keep putting them all together. That good? We know formulas like tangent is sine over cosine. Our trig knowledge is growing, and it's growing rapidly in the summer. It's about these double angle formulas. So they're going to ask you forward and backwards. So basically this time, they're wanting us to go backwards. They're wanting us to look and say, hey, which of the formulas is that? Look back at your formulas. Here they are. What do you see on the board? Where do you see that formula? Where do you see cosine squared minus sine? So let me go back here. Where do I see cosine squared minus sine squared? Well, right here. So what is it equal to? What is cosine squared minus sine squared the same as? Identical in value to cosine 2 theta. So what do you get what that means? That means if you remember, math and science is all about the pattern, huh? Look at the pattern. Look closely at the pattern. Look really specifically at the pattern. They're saying if you have some angle theta here, some angle theta there, cosine squared of that minus sine squared, that's going to be equal to, that's going to be the same as one simple cosine, but the angle's been doubled. Right? That makes sense? So, for example, if I said cosine squared of 30 degrees minus sine squared of 30 degrees, that's going to be equal to one simple cosine of what angle? 60. Because that's 2 times 30, huh? That'd be one example of that truth they're saying. Everybody see that? Saying if you have some angle over here, and you put double there, cosine squared minus sine squared of some angle here is a simple cosine of double that angle. That's what they're saying. Everybody see that form, what that pattern is telling you? Regular theta on the right side, 2 theta. You can do that anytime you want. They're saying those things are equal. They're identical in value. It's an identity. Right? Okay. So let's go back then. So they're saying this is really the same as what? Well, we just looked at it. It's one single cosine. So first off, they want me to choose multiple choice. Is it going to be the same as a single sine, a single tangent, or a single cosine? Well, option C, single cosine. That's what the formula says. Cosine squared minus sine squared is equal to a single cosine, not a single sine or tangent. Single cosine of what angle now? There's 180 here. So this will be 2 times 180. Yes, 360 degrees, huh? A single cosine of double the angle. That's what that pattern says, right? Single cosine of double the angle that you were using on the other side. And that's it. We're done with that one. Well, actually, no. Then they ask one more part. They say, okay, and what is the cosine of 360? The answer is from the unit. You just go to the unit circle. It's just 1. Right? Just go to the unit circle. You guys getting the unit circle memorized?
Sure.
Is that a silly question? Cosine sine, 360, cosine's 1. Right, cosine's just over. It's just over 1. Right? Just over 1, isn't it? To that point, at 0 degrees. Done. This homework's a lot better than last night's homework, huh? Is that good to there? No questions? Yeah. You know what? I think I didn't give you that formula. I was wanting to skip it, but it's like I can't, right? They're making me do it. Let me see, is that the one? Yeah, that's the one, isn't it? Yeah, that's the one. All right, I need to give you one more formula for I forgot, but I was trying to get out of tangent, so let me go back here and write it down. There is a tangent formula also. So here it is. Tangent of double an angle is 2 tangent of the angle over 1 minus tangent squared of the angle.
Which is the same as sine.
Or just sine 2 theta over cos 2 theta, which I think is way easier. But they're making us do this form. They're saying, if you ever see 2 tangent over 1 minus tangent squared, that angle, that's all the same as just one simple tangent of double the angle on that. Honey?
So on last night's homework, because we were just using that's the only formula we knew, the 2 tan theta over 1 minus tangent squared theta. If we were to just do sine over cosine, would that have been just as good?
On last night's homework?
Yeah, because, I mean, this was before we knew this sine 2 theta over cosine.
You have to show me the problem. Tangent is always sine over cosine. I can answer that much. Yes. So tangent is always just sine over cosine. You can always just do that for tangent. I'm afraid, though, there might be something else going on in the problem. I can't remember exactly.
Okay.
I'd have to see. But if there's nothing else, yeah. Tangent is always just sine over cosine. long as the angles are all the same. All right, so they're basically saying, look for that pattern. When you see 2 tangent over 1 minus tangent squared, that's going to be a 1 simple tangent as long as you double the angle. Okay, so let's go back then. So we say, okay, see what they have here? See how they're saying, okay, 2 tangent over 1 minus tangent squared, that's the same as what? You're supposed to choose multiple choice. 1 simple sine, 1 simple cosine, 1 simple tangent. Which one is it? 1 simple tangent of what angle, though? Double the angle. You guys with me? See that? So I got to take that angle they're using, which is 11 pi over 12, and go times 2. Which, right? So far so good?
Can we leave it in the pi form?
Let me write it right here to help you recognize. It says tangent of double an angle is 2 tangent of the angle over 1 minus tangent squared of the angle, right? That's the formula that I just wrote for you over there. So that, again, that means that when you do the 1 tangent alone, you got to double the angle. So that's all equal to 1 tangent alone, but you got to double the angle. What's the angle? 11 pi over 12? You got to double it. So now, how do you multiply fraction by 2? How do you double it? How do you multiply that fraction by 2? 2 over 1, cancel them out, 11 pi. So the angle is 11 pi. It's one. All of that is the same as 1 tangent of 11 pi. Wendy?
So you're just deriving that formula from the sum and difference formula?
That's how we get the sine and the cosine. Yeah.
That's 11 pi
right.
over 12, not 11 pi over 2.
Oh, thanks. I'm just messing up crazy. This is 12, so this is 6. Thank you, Wendy. Wendy, thank you, Pauline.
That's a compliment.
Okay.
Okay.
All right, we good there? Yeah, I just messed up. 11 pi over 12 times 2, cross cancel, 11 pi over 6. Everybody good with that? Everybody see how I did that? Right, so they're giving me this big old formula, which is the tangent one, and they're saying, what is it? All of that mess is equal to tangent of double the angle. So I double the 11 pi over 12. Cross cancel 2 into 12 6 times. The angle becomes 11 pi over 6. 1 tangent 11 pi over 6.
What about the denominator? Do you just not worry about that?
That's what they're saying. They're saying that whole thing. Numerator, denominator, squared, the 1, the 2 on the top, the whole enchilada becomes tangent. One simple tangent. That's kind of the weird and surprising thing. That whole mess can just be one simple tangent if you double the angle. Yes, that's what the formula says right here. It says 1 simple tangent of double the angle is equal to that whole mess. So that's what formulas tell you in math and science, right? That's what we call an identity. They're identical value. Even though they look very different in appearance, they are identical in value, is what that formula is saying. Is that good? Questions on that? All right. Section now. Now we're going to change half. First off, sine 15. If I wanted to find the sine of 15 degrees, could I go to the unit circle and get that value? Is it there?
No.
Do the 45 minutes.
Yeah, we learned yesterday, or Tuesday, a special way to do it, huh? Yeah. Now we're going to do it another way. Yeah, 2 days ago, Ani's right on the money. We did 60 minus 45, or yeah, that's what we did, right? No, or 30, 45 minus 30. Either way, you'd get 15, right? Because on Tuesday we learned how you add or subtract two angles. So we figured out a way to do this by subtracting. Right? You all know what I mean. It's because 15 degrees is not on my unit circle, right? Where's 15? It's not there. We start at 30. We skip from 0 to 30. 15 is not on the unit circle. Only way we could get 15 was with our calculator, and that's just a decimal that's an approximation, because decimal goes forever. So it's not, we can't cut it and say it's exact anymore. It's just an approximation. So how do we get then the exact answer? We got to do these tricks. Tuesday we learned you could just subtract two angles to get 15. 60 minus 45, 45 minus 30. Today we're saying, well, now another way is you could cut an angle in half. Take one that you do know and cut it in half. What's an angle that you do know that you could cut in half and then it would be 15? 30. So they said, hey, go find the sine of 30 degrees. Find out what that is. And 15 is half of 30. Now, does that mean you just cut the answer in half? No, it's not that simple, is it? What do you do? No, they're going to give me formulas. Let me just write them down here. They're going to say the sine of an angle over 2, half an angle. Now we're into the half angle. So today's double angle, half angle. Yeah, there it is right there on the board. Plus or minus the square root of 1 minus the cos of theta all over 2. So it's a little complex. You don't just say, oh, it's just going to be whatever the sine of 30 was, but just cut that in half. No, it's going to be that formula right there.
Would you get the same answer if we did the formula we learned on Tuesday?
You would get an answer that's equivalent. So it's the same in value, but it'll look very different. And Math Excel won't take it. It'll give you the although message. Have you got the although message before? Although your answer is equivalent to the real answer, we ain't giving it to you. Do it our way, right? Yeah, that's what they'll give you. So, all right, so we ready? So we're going to use that one, and then let me give you the other ones one more time here. Cosine theta plus or minus square root of 1 plus cos theta all over 2. And then tangent theta over 2 plus or minus square root of 1 minus cos theta over 1 plus cos theta. Good? All right. Well, let's go back and use it. So what we're saying, see the pattern. Let me go back. Let me help you observe the pattern. Math, science, all about patterns. They're saying, say you have the sine of some angle over 2. That's going to be plus or minus the square root of 1 minus the regular cosine over 2 like that. Okay? So let me put it right here for us to look at. Sine of theta over 2 is plus or minus square root of 1 minus cosine theta all over 2. So there it is. So sine of 15 then is going to be the sine of 30 degrees over 2, isn't it?
Okay.
Right? Isn't 30 over 2 15? Right?
You've got to double it first.
Yeah, you got to double it so that half of it's the same.
Gotcha.
Did that sentence make any sense? See the game we're playing? 15 is half of 30. So now, follow the yellow brick road. You will get to see the wizard. You will get your answer. If you follow the pattern, stay on the path. What's the pattern? It's saying, whatever you put up here, I'm putting 30 up there, aren't I? Isn't that slot? It's saying, whatever you put on top of the 2, call that thing theta. On the other side, write plus or minus, and put a big old square root, and go 1 minus the cosine of that thing, all divided by 2. See how I followed the pattern precisely? You see that? They're saying whatever you put over 2, that thing right there is what goes on the other side of the cosine. Isn't that what that pattern says? And that I can do, can't I? I can get the cosine of 30 off the unit circle. So if you go to the unit circle, cosine of 30 on the unit circle is root 3 over 2. Right? Cosine of 30, here's 30. Cosine sine. Cosine's root 3 over 2. So what does that give me then? I've got plus or minus the square root of 1 minus the square root of 3 over 2 all over 2. Yeah.
What if the angle is not in the unit circle?
What if the what's that?
The angle is not in the unit circle.
Then I put it in the unit circle. So in other words, remember, when somebody gives you an angle, they're saying an amount of opening, like, I could go 45 degree opening, right? I can make my hand, the angle go out as much as I want. You could have a gigantic door that you open 45 degrees, or a really bitty tiny door that you open 45 degrees. It's the same angle, just because the sides go further or not So that's to answer your question about unit circle. So that I'm forcing them on the unit circle. I'm saying I'm stopping it at 1. I'm not letting it go past the unit circle. Right? Does that make sense on that?
No, I wasn't trying to say that. For example, in the unit circle, they only give me like 45, 40 degrees.
Oh, like that. I'm sorry. Yeah, I hear you. Yeah, what if it's one of those not? Yeah, you got to make it one of those on the unit circle. Yeah, so good question. So when I look at 15, I've got to double it so that 30 is on the unit circle. That's exactly, because I can't do 15. It's not there. So I double it, 30, and then I can go find 30. Yeah, it's got to be something I can get on the unit circle. So we good to hear? We got to simplify that now. Hey, what's with the plus or minus thing? Which one is it? Plus? They're giving us two options, plus or minus. What's the angle? We're answering what the sine, all this stuff is what sine of 15 equals, right? That's what we started with. Sine of 15 equals this, equals that, equals the other thing. The sine of 15, so you tell me, 15 degrees, what quadrant's that in? First quadrant. What's the story about the signs in the first quadrant? All positive. So forget about the negative. This is positive. So it all depends on what quadrant your original angle is in as far as the plus or minus. Is that good? Just do the all students take calculus. Now I've got to simplify this thing. How do you simplify that thing? It's dividing both these guys by 2, isn't it? A 2 there? So let's just go. It's a half minus root 3 over 4. I'm running out of room. Let me back this up. I need a little more room. It's positive, the square root of 1 minus square root of 3 over 2. So just put it underneath both of them. Is that good? See what I did there? I took that 2. 1 is being divided by 2, and the fraction is being divided by 2. When you divide by 2, you double the denominator, huh? Everybody okay with that? Why? Because it's 2 over 1. Flip it up. It's 1 over 2 and 1 over 2 for both. That's another way you could see it. When you're dividing by 2, that's to remember we've talked about how dividing is upside down multiplying. You're dividing them both by 2. You flip it up, 1/2, 1/2. That's 1/2 minus root 3 over 4. Is that good? Just double the denominator. That's another way of cutting something in half, isn't it? When you divide by a number, that multiplies the denominator, doesn't it? Do you ever think about that? Do you ever stay up late at night and think, hey, dividing is the same as just multiplying the denominator? No. Strange math teachers do, huh? So that's true, isn't it? Dividing is the same as multiplying the denominator. If you multiply on the bottom, you divided, really. Didn't you? So when they're both divided, because I'm sinking this in because it's going to get ugly in a couple minutes, and I want to be able to skip some steps when it's terribly ugly. It's going to get terribly ugly in just a couple minutes here. And there's going to be so many fractions everywhere, and I'm not going to want to write all this. There's just plenty of other things to write. I'm going to go, hey, let's just double denominator, double denominator. That is divided, right? We good with that? So we get to here. Now, why aren't I done to here? Well, what do you got to do when you got two fractions? Common denominator. So, common denominator, multiply top and bottom by 2 to make both denominators be 4. Are we good there? Okay, so what do we get? 2 4s minus root 3 over 4. In fact, let's just make it 1 4 on the bottom, right? 2 minus root 3 all over 4. Good? Is that okay? See how I made both denominators become 4, so you can just make one big bar with the 4? You good there? Now we're almost done with this one. Why aren't I just done right now? Well, there's a root over the whole fraction, isn't there? Which means root over the top, root over the bottom. It's going to be kind of weird looking. It's going to be double rooter. So root of 2 minus root 3 over the root of 4. But what is the root of 4 on the bottom? That's just 2. I'm just going to make that into 2. Done. There's my answer. Did I lose you in the mist of all that?
Are you allowed to have a root inside of a root?
Yeah. There's no laws against it. It's kind of weird looking, huh? You're not allowed to have a root in the bottom, but you're allowed to have roots in roots.
You don't have to use it out?
What's that?
I would think they would have.
I just see.
Don't like that, huh? Don't approve? Bernadette, no?
There's so many other little rules, but this is the one where they're like, oh, that's okay. You
Yeah.
know, like.
We like that. Is that good? Everybody see that? So you okay? I know this is where it gets tricky, and we're going to get really worse in a second. So I want to make sure, are you okay with this one? This is just medium level. You good how I got common denominator here? You have two fractions, common denominator. Make that 2/4. So 2, and then the root. Then you have a root over a whole fraction. That means you root the top, root the bottom. So you put the root on the top, it just stays, but the root of the 4 on the bottom is 2, right? All right, I'll quit beating that drum. So number 8, tangent of 105 degrees. How am I going to do the tangent of 105 degrees? Let's go look to the unit circle. 105 degrees. Let's see if we can find. Okay, 105 degrees. Is it there? 105 is not there. Here's 90. Here's 120. 105 should be between them. It's not there. So there's no way to get an exact value straight off the unit circle for 105 degrees. We can use our calculator, but that's just an approximated decimal. How am I going to get the exact value for tangent of 105? I'm going to have to use some trickery. Actually, we could do this one using yesterday's stuff also. What could we do? What two angles could I add? What two angles that are on the unit circle that I do know exact values for could I add to get 105? 60 and 45. So you really could just do it the way we did it yesterday. Now, you want to, well, then why are we doing this new stuff? There are some new things. Like, for example, how could you do half of 45? 22.5, half of 45? Couldn't do that yesterday. Tuesday. 22.5, can't get that by subtracting any two angles. So there are new things that this will do that the other didn't do. They're just happening to give me questions that we could do with yesterday's. So anyway, I got to do it the new way, tangent 105. So I'm going to use the tangent formula, which says tangent theta over 2 is plus or minus the square root of 1 minus cos theta over 1 plus cos theta. Like that. Yeah, that one. Okie dokie. You ready? We're going to use that one. See how it's going to work. They're saying tangent of 105 is equal to, what can I put up here? What's my theta going to be so that theta over 2 is the same as 105? You double it, right? You double it. Is that confusing how half-angle formula requires you to double it? Because you're saying 105 is half of what bigger angle that I do know? It's half of 210, isn't it? So I'm going to find 105 by doing half of 210. Because 210 is on my unit circle, right? 210 is right there. You see? So I'll use the information, the cosine and the sine for 210 and some other stuff to figure this out. So let theta be 210 degrees. Theta is 210. So theta is 210, which means this is 210, and that is 210. And that'll be the tangent of 105, actually. Does everybody see that? How are we doing? It's making good sense? It's making no sense? So 105 is the same as 210 over 2, isn't it? You see the idea? 105 is the same as 210 over 2. So I can plug in, so I'm letting the theta be 210. All right, so here we go. It's going to be equal to plus or minus the square root of 1 minus cosine 210 over 1 plus cosine 210. Now, is it plus
Yeah,
or is it minus?
it's a plus. Because it's in the third quadrant.
Okay, which actual, now go
Oh, wait,
back
no,
to
never
the
mind.
beginning.
It's in-
Which angle, should we use the 105
It's in,
or
yeah.
should we use the 210? What are we really figuring out here? Because this is the sign in the front of the whole thing, isn't it? Plus or minus. That's in front of the whole thing. So is the whole thing, it's 105 we want to
So it's
look
in
at.
the second quadrant, so it's negative.
Right. Everybody see that? It's the 105 that we're really figuring out. We're using 210 to help us, but what we're really answering is what is the tangent of 105, aren't we? Am I doing the 111? Am I coming across now? I'm getting some kind of blank stares.
It's negative.
Is this making sense? We're really answering the tangent of 105. We're using 210 to help us. But really, we're answering what's the tangent of 105. So 105 is our actual angle. Where's 105? Here's 0, here's 90, here's 180. 105 is somewhere in the second quadrant, isn't it? What's the story with the sign there? All students. Oh, sign is positive in the second quadrant, but all the rest are negative, including tangent. So get rid of the positive. We're talking about a negative root on this one, aren't we? Good? All right, let's do it now. What's cosine 210? So we got negative square root of 1 minus, go to the unit circle, cosine 210. 210, cosine, negative root 3 over 2. Negative root 3 over 2. 1 plus negative root 3 over 2. Watch out, you got the double negative on the top. Is that good?
So really, those signs are going to be flip-flopped.
It's just going to be a mess. Yeah. All kinds of things are going to happen now. So, okay, so now begins massive simplification work. Minus, yeah, the double negative here is positive. 1 plus root 3 over 2. 1 minus root 3 over 2. Yeah, they just flip-flop, that's right. Good to there? That one's got a lot of simplification needs. He's a mess. He's got, look, let me make a few cursory observations on all of his problems. He's got fractions over fractions. We can't have that. He's got a square root in the denominator. We can't have that. He's got a square root over the whole thing, which means another square root in the denominator and the numerator. We can't have that. He's got 3 big issues that we have got to clean up, and clean up before he is an acceptable answer. Clarence?
We cannot, well, can we start with the fraction lower part? The bottom, 1 minus root 3 over 2.
Right, can we start? What I'm going to do, I'm going to handle them both. Well, yeah. Well, it depends what you mean by starting with it. I'm going to actually do all the ones. We can't grab this and flip it up, right, because of the glue. So I'm not sure if that's what you meant, but yeah. If the glue there says these guys are not separable, are they? They are glued together, right? I can't grab this part and flip it up. It's glued to the 1. If that was times 1 times it, I'd flip it up, wouldn't I? Everybody good with that? Getting all those glue rules down? All right, so instead, let me go to a fresh screen here. So what is it? It's negative square root of 1 minus root 3 over 2 all over 1 plus root 3 over 2, right? No, other way around. Plus on the top, minus on the bottom. Okay. So, all right. So first off, how can we handle it and to get rid of these extra 2's? We don't want fractions within fractions.
We can multiply by 2.
Everybody by 2. Cancel, cancel. We get minus the root of 2 plus root 3 over 2 minus root 3. A little better? We took care of one problem. Everybody see what happened. I multiplied top and bottom by 2. Everybody by 2. That's totally legal to do. Right? Doing the same thing top and bottom. So, not really changing anything. So that's one issue. Next issue is we can't have a root over an entire fraction like that. In fact, what does a root over a whole fraction mean? I'm just going to do it right here. It means, well, here, let me just leave it here. I'll come down to the next line. It means the root is on the top and the root is on the bottom. Huh? See that? See how I just took that root that was over the entire fraction and I put it on the top and the bottom. That's the same thing, right? You know, if you have a root over 7/11, that's the root of 7 over root of 11 to make a simpler same case. That's all I did, really. Everybody see that? That's the pattern I just followed. Have a root that's over an entire fraction, it means root of both, doesn't it? It means root both the top and the bottom. So this root that was over the whole fraction, I just rooted the top and the bottom. That's in addition to the little root on the 3's. Okay. So we cannot have, the one on the top is fine, we're fine, and Bernadette especially enjoys, the root over the root in the numerator. We're fine with that. That's not a problem to us. But we don't like it on the bottom. There's no roots on the bottom. We got double root problems on the bottom. So we got to get rid of those. Too bad I can't just erase them, huh? So I have to get rid of them. How do you get rid of a root when it's over a whole number? Like if I had root 7 over root 11, how would I get rid of that root from the 11 on the bottom? I would multiply top and bottom by root 11, right? Because on the bottom, root 11 be plain 11. Remember the fundamental root rule. It's a 2-for-1 deal at Target. Is everybody clear on that? As we're going into this root world now, you got to know that like the back of your hand. You got to know that really clearly. From algebra, that was something that at least you were supposed to study. Root 11 is plain 11. Remember, roots are a 2-for-1 deal. That's why they're called square roots. Square means 2. Right? Cube means 3. Square means 2. Square root. 2-for-1 deal. 2 11s in, 1 11 out. You with me? What if there's root 23, root 23? It would be plain 23, right? 2 23s in the root multiplied is 1 23 out of the root. So the root of blah, blah, blah times the root of blah, 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 no matter how big the blah, blah, blah is, if they are the same, it's 1 blah, blah, blah no longer in the root. That's the pattern, right? Math is just patterns. That's the pattern it's showing. If you got 2 of the same thing in a root, that's 1 out of the root. 2 in the store at Target, you can go out of the store with your item, paying for 1. 2-for-1 deal. 2 in, 1 out. So that's the deal. So what does that mean I'm going to do with this fraction? I'm going to come in here and go, okay. I got to multiply by that whole denominator. Now, this is not conjugate. I know you might be thinking, wait, didn't we learn conjugate? I know that's what's confusing. It is. This is very subtle. If it didn't have this root over it, if it was just 2 minus root 3 without the outer root, if this outer root was missing, then yeah, I would totally do conjugate. I would say, look, that's a root and something, and I would do the opposite, which we're going to have to do in a minute. Anyway, but because it's got the root over it, I'm really saying it's got a whole root on the bottom. It's not really 2 separate things right now. It's 1 big root over that whole bottom. So then I've got to multiply by the same thing, top and bottom. All right, I'm just going to move ahead. I hope that's good. I know this is a tough one. Keep going. Okay, what's going to happen on the bottom?
It's going to be 2 minus root 3.
Yeah. See what just happened? We got this inside. 2 of the same thing inside leads to 1 out, right? 2-for-1 deal at Target. 2 in, 1 out. See, we have 2 minus root 3, 2 minus 3, both in roots. Now, 2 minus root 3 out of a root. So I'm not going to put a root over that. It's out. Came out of the store. Just one. What happens on, is that good? What happens on the top? Can we do that on the top? Can we just go 2 in, 1 out?
Can you foil?
No, they're not the same thing. They're not the same thing. Yeah, so they're going to, I got to keep that minus sign also. The minus sign, but I want it in the front really here. So let me put that minus sign in the minus sign still there. Anyway, yeah, you just got to throw them both in the same root. There's nothing more you can really do. 2 plus root 3, yeah, we're going to FOIL them. And 2 minus root 3, all together under one root. They don't get to come out because there wasn't 2 of them, not 2 identical ones. Everybody see what happened there? So on the bottom, it was a 2-for-1 deal. Because they were identical, 2 identical in roots is 1 out of the root on the bottom. But on the top, they both got to stay in. See how they're both still in a big root on the top? They just go together in one big root and they got to FOIL them. So FOIL now. So bring it down to here. Going to FOIL, going to keep that negative in the front. I'm going to FOIL the top. What do we get? 4 minus 2 root 3 plus 2 root 3 minus plane 3, all still in a root. The bottom, 2 minus root 3. See what I did? See how I FOILed that top? Can you do that FOIL? See how I just took this 2? It's first to both, second to both. And root 3, 2 3's in, 1 3 out. See how that 1 3 came out? Everybody seeing that? See how root 3 made that 3 come out? You see that? 2-for-1 deal. Target. 2-for-1 deal. That's what roots are. 2 identical in a root, 1 out.
We just got rid of the root 3 on the top.
You good to there so far? There's a couple more steps. This is like one of the worst. This is probably the worst problem in the homework right here. Let's keep going. We're almost there. These guys cancel, don't they? Mm-hmm. Yeah. Oh, that's what you were saying. Yeah. Those are gone. So it's just 4 minus 3. That's just the root of 1. That's beautiful. That's just 1. See what happened up there? Isn't that nice? Square root of 1 is just 1. 4 minus 3, that's 1. Square root of 1 is just 1. Are we done? No, we're still not. No, we're close. We still have a root in the bottom.
Now we do the conjugate.
Now we do the conjugate. Everybody seeing all those steps? This is what makes you a master of algebra. This is what you need if you want to go on to pre-calc and calc. You got to learn out these rules. Yeah.
What if you had a root 6? You know where the 1 is? The root 1. What if you had a root 6 there? Would you do 2 root 3? I mean, like, oh wait, no.
If this was root 6, you're saying?
Yeah.
Would I do what?
It just stays root 6, right?
Right.
I was going to say mine's a 7.
So now, last thing is I'm going to come up here if it's okay. I'm just totally running out of rooms. We're on the second screen for this crazy long problem here. So we have minus 1 over 2 minus root 3. Right here, let me put the minus in the front. Minus is in the front. 1 over 2 minus root 3. You know the drill. We can't leave roots in the bottom, huh? So now we do conjugate. 2 plus root 3, 2 plus root 3.
We don't do anything with the negative in the front, right?
Right, just sits there.
It just sits,
It just sits
it
there.
doesn't affect the conjugate.
Nope, not at all. So everybody see that? Remember conjugate? Remember when you have a root and a plus or minus in the denominator, gluing them together, that's when you use exactly what you have with the opposite sign in the middle. Use the whole denominator, but opposite sign in the middle, top and bottom. That's conjugate.
Okay, so if you do have a root, like mine's a root 7 at the top,
Uh-huh.
when you're multiplying the 2 plus root 3,
Yeah. Outsiders stay outside, insiders stay inside. So if I had root 7 multiplying 2 plus root 3, yeah, because some of you might have that, and you go boom, boom, it'd be 2 root 7. See how this outsider is an outsider, and the 7, they say it's a plus root 21. They can multiply 3 and 7 because they're both insiders. Yeah, that's the rules for roots. Outsiders with outsiders, insiders with insiders. You know what the perfect analogy is? It's like jail, right? Outsiders can interact with outsiders, and insiders can interact with insiders. There's no crossing the line. You can't go into jail unless you commit a crime, and then you're in. Right? There's no crossing the line. Reminds me of my father-in-law, my wife's dad. He played football for Sac State back in the day, and they played against the local, I think it was Folsom Prison, one of the prisons right around there. I think it was Folsom Prison. Isn't that in Sacramento? Folsom? Anyway, it's getting loud. So, and they played against Sac State football team. He told the story that when they went in to play the prison, when the Sac State football team went to play the prison, they stamped their hands going in because they're not insiders; they're outsiders, right? They stamped their hand going in so that if during the middle of the game one of the prisoners tried to knock out one of the football players and take their uniform and walk out after the game, they would know they didn't have a stamp, right? So they stamped them going in. They played the football game. My father-in-law, he played linebacker for Sac State. His forearms are as big as my thighs. And it's always been very good. If I was ever unkind to his daughter, he could just break me like a stick. It's been very, very good. I love his daughter, so it's all worked out just fine. But anyway, so he told me they're coming out of after the game's over. Sac State football players are walking out of the yard, and they're all serious. The guards are up there with their guns, and it's serious business. Anyway, Dad got it wiped off. He just got the stamp just during the game, rough and tumble. He just got the skin and everything just wiped off. So there's no stamp. So he's walking out. The guards see that they're looking at the stamp, so the guy's going by, and he stops them. And they know that happens, so they're not alarmed. And they stop him at the gate, and they look at the coach, the Sac State football coach up there, and he goes, "Coach, this one of yours?" And the coach thought it would be funny at that point, because there's no stamp there, right? He goes, "No, never seen him." At that point, they grab Dad and throw him up against the, 3 or 4 guards grab him and throw him up against, put the baton under his neck, and all that kind of stuff. And the coach, "Oh, no, just kidding, just kidding." At that point, they grabbed the coach and they said, "We're not messing around with the guys with the guns or, So it's serious. So it's a big deal whether you're an insider or an outsider. There's no crossing the line. That's the rules for roots. So when roots interact, remember, insiders interact with insiders, outsiders with outsiders. So when that root 7 goes boom, boom, the 2 stays outside, but the root 7 and root 3, they would both go inside. Insiders with insiders, outsiders with outsiders. That's the rules for roots. Okay, so as we do this one then, so the minus is staying in the front. The 1 multiplies boom, boom, 2 plus root 3. On the bottom, what's going to happen on the bottom? Here we go. We're going to FOIL it. 2 times 2, 4. 2 times root 3? Yeah, outsider stays outside, insider stays inside. No crossing the line, right? That one's done. Boom, boom. Minus 2 root 3. And what is minus root 3 times plus? Plus times minus is minus. Root 3, root 3? Plane 3. Everybody good with that? Root 3, 2 in, 1 out. Or you can make a root 9. What is the root of 9? Plane 3. Same answer either way. See that? 2 3's in, 1 3 out. What happened? We're so close. We've been doing this problem forever. Those cancel.
That's how I felt last night on those problems.
Yeah. And we got minus 2 plus root 3 over what? 1. 4 minus 3 is 1. Oh, getting in the way here. We good there? It's over 1. Well, do we leave 1s in the bottom of fractions? No, it's considered unsimplified. We never leave 1s. So the answer is minus 2 plus root 3. Good work. All that work.
Now, if This,
Pauline, do you have a problem with that answer?
no, I'm just trying to figure out my own problem because it came out wrong.
I think you should have a problem. I was hoping you had a problem. We should all have a problem. Hold on then, because I thought you were going to comment on my answer, because my answer is wrong. Wouldn't it be a bummer to do all that good work, and I just dropped the ball? I fumbled on the 1 yard line at the last step. This does not equal that. I hope you know.
Does the negative affect both numbers?
Both. That's got to go there too. What you think? Well, why? No. Where? Think about it with me. Where was he? He was in the front. He was in the front. Which means he what? Is he affecting the whole fraction or just playing favorites? No, he's affecting the whole fraction. He's the negative on the whole fraction. So when the bottom vanishes, he doesn't just go to the front guy. He goes to the whole numerator, right? It's got to go to both. Now it's right. Was that what it was? Was that what your issue was? No, okay.
Well, yeah, but
Different numbers,
so
same thing?
yeah, but I've got a negative and a negative,
So it changes to negative and positive.
but it's still not taking.
Oh, it's something else then. Anyway, is that good to there? So everybody said that negative has to hit both those. Why? Because it's got to distribute. It's got to affect the whole numerator, not just the front part. Right? It's negating the whole fraction. And the bottom has vanished, so it's got to hit both the tops, right? But I see that mistake all the time. Is that okay? Does everybody see that? It's all these little rules that you got to get down if you want to go to higher math. It's all.
Be an option on the test?
Yeah, it might be. I don't know. The publishers make those options. Yeah, they probably. Sometimes they do that kind of thing, don't they? Is that good? Is that okay? Did everybody see that? So when a minus, so you got to think right about minuses. When a minus is in front of a fraction, that means it's going to affect the whole numerator or the whole denominator. Either one, not both. And so when the bottom vanished, it goes up to the top and affects the whole thing. Like that, not just the front part. All right, that was a terrible problem, wasn't it? We got to do one more. That was terrible. Got to do something a little easier than that. Questions on that one? Try this. Sine of theta over 2. So grab the sine theta over 2 formula. Sine theta over 2. So they're going to go back to you. That was the hardest one in the homework right there. Now it's sine theta over 2. The formula says plus or minus the square root of 1 minus cos theta all over. Oh no, that 2 is in the root, isn't it? Watch out. Don't make that mistake I just made. Right here. I don't like. Well, there's stuff everywhere. 1 minus cos theta all over 2 like that. Right? Yeah. So there it is. There's the formula. They're giving you the triangle on the right side. Can you see those numbers? Here, I can maybe make this one bigger. Number 9. Giving you a triangle over here. It's something 24, 25. And theta's there. There. Okay, so it's the square. It's plus or minus square root of 1 minus cos theta all over 2. Like that.
Was it the question mark 7?
Oh, was it? Oh, that'd be better. I don't want a question mark. Yeah, thank you. Just my eyes. I'm getting old. I can hardly see it. 7. There we go. Thanks. Okay, give that one a try. So, yeah. So we need the cosine of theta, don't we? Right here. So what's the cosine of theta? Remember SOHCAHTOA So cosine adjacent over hypotenuse. So this is opposite, adjacent, hypotenuse. 7/25. So grab that and put it in right there. So we get plus or minus the square root of 1 minus 7/25 over 2. Not making sense? Is that good to there? So what are we going to do now to handle this complex fraction? Oh, no, we just need to, it's just this. We just need to work this out now. So that 2, that means they're both divided by 2, right? So it's 1/2 minus 7/50. Is that okay? See how I just divided them both by 2? Is that good? I just put the 2 under there and under there. Is that good? Everybody see what happened there? I just divided both those guys by 2, which means doubling that denominator, right? Doubling 25 to be 50. Now, how can I, right, because that's what it means to divide by 2. How can I subtract these now? Common denominator. So that means 25 top and bottom. Plus or minus. And we come up to here. Is that 18? 50ths? So everybody good there? How are we doing? Okay, and what can I do with that? I can reduce that fraction, can't I? Divide by 2. So that's plus or minus the square root of 9/25. And so what's that? Plus or minus square root of 9/25?
3 over 5.
Right? Yeah. Square root of 9 is 3. Square root of 25 is 5. Is that good? And last thing, is it plus or is it minus? Which one is it? We don't know. It's just some theta in the middle of a triangle. We don't even know what the angle is, do we? It's just theta in a triangle. Oh, but hold on. It's in a triangle. We got to figure, to know plus or minus, we got to know what quadrants it's in, right? First, second, third, or fourth quadrant?
If it's in a triangle, then it has to be less than 90 degrees.
Why, Bernadette? Right.
Because it, well, 90 degrees is there. And
Yeah.
It has to be.
Right? Everybody hear what Bernadette's saying? Triangle holds 180 total, right? And this right angle's already using up 90. So the other two angles have to be less than 90.
So it's going to be positive.
Right.
It's in the first quadrant.
Right. So this angle, so whenever you're in a triangle, you got to be less than 90 when you're in a right triangle. Because the right triangle's already using up 90 of the 180 total. There's less than 90 left to go for the other ones.
Always be positive.
So it's always going to be in the first quadrant, right? If you're less than 90, remember the 0 degrees, 90, 180, 270. So if you're less than 90, you're somewhere in the first quadrant, aren't you? Right? You see I'm saying that theta? Whenever you're in a right triangle, you got to be less than 90. Because there's only 180 total in there. And the right angle is already using up 90. So this has to be less than 90. So if it's less than 90, somewhere in the first quadrant where all are positive, huh? All students take calculus?
Yeah.
All the trig functions are positive in the first quadrant. So if you're in a right triangle, you're less than 90, you're in the first quadrant, you are positive, not negative, for sure. Yeah?
Yeah, but how do you know you're in the first quadrant though? Like,
They drew that picture, and they put theta right here in a right triangle.
yeah, but that could be in quadrant too, because that picture looks like it could be in.
Oh, no, it's not sitting, this is not sitting on a coordinate system.
Oh.
It's just a physical right triangle all by itself.
Well, I mean, like, still, how would you know that's in quadrant 1?
I'm just, remember, what theta is this is the amount of opening here. This amount of opening right here has to be less than 90 degrees.
Yeah, and it's always going to be less than 90 though, right?
So I know it's confusing about the quadrants. Like if we do something in the second quadrant, for example, and I know we put theta here, really though, theta is this angle. Theta is getting us there, and we're just using the reference. So if you're in a right triangle, you are less than 90. See, this isn't sitting on, what you're thinking of, Ani, is when they're on a coordinate system. That's not on a coordinate system. That can't be in the second, third, or fourth. There's no axis there, and that matters.
Okay.
It's just alone. It's not sitting on a coordinate system. It's just in a right triangle alone, like that. All right, well, we need a break at that point, huh? 10-minute break. Okay, so number 11, they're saying tangent alpha is negative 12 fifths, and alpha, notice, is an angle between negative and positive 180. Yeah, this is a little tricky. Yeah. Okay. So what are we going to do? Got to choose a quadrant, draw a triangle. That whole thing. What's that? Yeah, that whole, draw the triangles like you guys are used to. So go ahead and start with that.
Okay.
Draw the triangle, put it in the whatever quadrant it belongs in, and, do the SOHCAHTOA and the Pythagorean Theorem and all that.
A is less than 180, but greater than 90, so 10 of
Does everybody see A is between 90 and 180, huh? That's the second quadrant. We all good with that? Right, because 90 is right here, 180 is down there. Right at the angles between 90 and 180, it's in the second quadrant, isn't it? Good? It's in the second quadrant. So that's where our angle A, or whatever you want to call it, is there. And they're telling us tangent, can you read that there? It says tangent of angle A is minus 12 fifths.
13, because that's one of those.
5, 12, 13. 3, 4, 5. Remember those two. Save a little bit of time. Yeah, put them on your card. 3, 4, 5, 5, 12, 13. Okay, tangent. Remember the SOHCAHTOA. SOHCAHTOA. Tangent is opposite over adjacent. So opposite over adjacent. So this is the opposite side, adjacent side, and the hypotenuse. So opposite is 12, adjacent is 5. Hypotenuse is going to be 13. Remember 5, 12, 13? Don't even need to do the Pythag if you just remember 5, 12, 13.
Do we need to make 5 negative?
But yeah, right, because it's back and up. So it's negative 5, positive 12, isn't it? Back and up. Or you could just remember the all students take calculus and get them that way. Good to there? Now, we're ready to go. Now that we got our triangle, we're ready to answer their 3 questions. First off, sine of A over 2. So we're going to use the formula for sine A over 2. which is, in fact, let me just write it up here. Sine of a over 2 is plus or minus the square root of 1 minus the cosine of a all over 2.
It's gonna be positive if no sign.
We'll talk about it. Let's save the sign thing.
Okay.
Well, okay, we can talk about it now. I guess it's right there in the front. Let's decide, is it positive or negative? Right, we're giving this the two options, positive or negative.
I think it would be positive because all students.
What quadrant is it in?
It's in the second quadrant.
What is the it I'm referring to? What is it? What are we trying to take the sign of? A? A over 2.
Oh.
A is between 90 and 180. A is in the second quadrant. But they're not asking me for the sign of A. They're asking me for the sign of A over 2. That's the curveball in this problem. Do you see what they're doing? That's where it's hard to keep everything straight. They're asking for the sign of A over 2, not the sign of A. We're using A to find the sign of A over 2.
So it's going to be in the first quadrant.
Yeah. A over 2 is half of A. So if A is between 90 and 180, cut those both in half.
So 45.
45 and 90. A over 2 must be between 45 and 90, right?
So it's going to be in the first quadrant.
45 and then this is 45 in the middle. This is 90 right here. That means it's in the first quadrant.
So it's still going to be positive.
Yeah, but when we got to the cosine, it would have been a
Yeah.
problem. When we get to part B. They're all going to be positive in the first quadrant. Did you follow that? Does that make sense? They're actually asking me for the sign of A over 2 right here. So A is between 90 and 180. Divided through by 2, A over 2 is between 45 and 90, isn't it? I just cut 90 in half and 180 in half and got A over 2 is between 45 and 90. So A over 2 is in quadrant 1. So A over 2 is quadrant 1. So they're asking me for the sign of A over 2. That's what you got to be clear on. All three of these, look what they're asking. Sine of A over 2, cosine A over 2, tangent A over 2. They want to know A over 2, not A. So we want to look not where A is, but where half of A is, A over 2. Right? And they told me A is between 90 and 180. So then A over 2, cut those in half between 45 and 90. So they're all positive. Because A over 2 is in quadrant 1, where they're all positive. Is that making sense? Right? Quadrant number 1. See the difference between A and A over 2? They're asking me for A over 2 in this question. So A over 2 is between 45 and 90. Quadrant number 1. Everything's positive in quadrant number 1. So it's going to be positive, the square root of 1 minus the cosine of A. Now what's the cosine of A? Cosine of A,
Oh, negative 5/13.
adjacent over hypotenuse, right? Remember SOHCAHTOA, adjacent over hypotenuse. Negative 5/13, huh? So it's negative. They're going to double negative here. Negative 5/13 all over 2. Everybody see that double negative thing? Right, adjacent over hypotenuse, negative 5/13. Is that good? Now what do we do with this 2? He divides them both, doesn't he? It's going to be 1/2 plus 5/26. Is that okay? Done this a couple times now, let's get more comfortable. It's the kind of thing you just do it again and again, pretty soon it gets comfortable. Everybody good with what happened there? The 1 over 2 and the 5/13. I doubled the 13 to be 26. Okay, so now to add those together, I got to multiply top and bottom by 13. And I get 13/26 plus 5/26, which is 18/26, which is 9/13. When I reduce it, I'm going too fast. Is that good? Top and bottom by 13. Make the denominators both 26. 13 and 5 is 18.
Does it matter if you reduce it before or after you
Root it?
root?
I would definitely reduce it before. It doesn't technically, but I think it's be quite a bit easier for you in general. There'll be some where it really makes a difference in ease of use. It's okay. There's no official law against either way. So root of 9/13. Here, I need more room. I keep thinking these problems just kind of go forever with reducing and common denominators. So bring it over here. All right, so I'm getting the root of 13/26 plus 5/26, which equals the root of 18/26, which is root of 9/13. Right? Divide top and bottom by 2, 9/13. Now, how do you square root 9/13?
You separate them.
Root, separate them. Root top, root the bottom, right? Root 9, root 13. But what is the root of 9?
3.
That's just going to be 3 on the top. But the root of 13, I can't leave it. So what do? Multiply by root 13 over root 13. So you get 3 root 13 over 13. There it is. Yeah. And that's just part A. That's just the sign. I don't feel like doing B and C. So I'm going to let you do that. I want to get on. I really got to get onto the other stuff or I won't be serving you well. So I'm going to get onto the other stuff.
So you're going to leave us to do tangent all on our own.
Yeah, I would just divide sine by cosine. Once you get the answers for sine and cosine. Yeah. Just do that.
Instead of doing that code.
The whole other thing. Yeah, just do sine and cosine. Just divide them. All right. Enough with this section.